here. There is a thing which is very important to learn. It's called triangle law of vector addition. So my dear, you see there are different types of vectors like velocity, momentum, force, acceleration. There are different types of vectors are there. For example, I'm taking one vector, that is force. Suppose there is a football here. On this football, you are applying force on different directions. Like you are applying force from this direction, this direction. One, you are applying force from this direction. Two, you are applying force from this direction. Three. So if you are applying three different forces on a ball or any object, and the ball is in still condition or the ball is in equilibrium, then we can say that sum of all forces is equals to 0, or in a broader perspective I can say sum of all vectors is 0. If sum of these vectors, three vectors, is 0, that means they are in balanced situation. That means we can say they can be represented by sides of a triangle. Okay. For example, I'm drawing a triangle here. I'm drawing this triangle here. We can label this triangle as A, B, C. If you are applying force which are represented by the sides of this triangle and the forces are in balance or the vector sum is 0, then AB vector plus BC vector plus AC vector is equals to 0. What you can do now, you can transfer one out of these three values. Suppose I am transferring AC, so we'll get AB vector plus BC vector is minus AC vector. That minus AC vector can now be represented or replaced by CA, because CA is just opposite to AC. So what you notice here, AB vector plus BC vector is equals to CA vector. So we have a learning here that if we are representing three vectors with the sides of a triangle, then one vector will always be equal to the sum of other two vectors. Okay, how we find this relationship? Look, AB, you are standing at A, you are going in this direction AB, then BC. To complete the cycle, again come at A and move in the opposite direction. AC. Oh, there is an error I have made in the beginning of the concept. When we were moving in a cycle, it was AB, BC, CA. So it should be written as CA. C. When we transfer the CA there, we get minus CA, and that is equal to AC vector. Okay, so we have a learning here. Similarly, we can write, if I stand at this point B, then we write BC plus CA equals to, again reach at B and move in the opposite direction. You can also write, you can stand at C and you can write like this, CA plus AB equals to what? CB vector. You understanding it or not?
CA plus AB equals CB, yes.
Yes. For two sides, stand at any point. For two sides, move in the straight direction, and for the third, move in the opposite direction. That's it. So if we go back to our example here, the example is this: in triangle P, you see PQS. We have three sides: PQ, QS,